Welcome learners. Our lesson today we're going to look at water and hydrogen. Subtopic is hydrogen gas. We first begin by looking at the laboratory preparation of hydrogen gas. Now reagents used is zinc granules and dilute hydrochloric acids. Catalyst used is copper sulfate crystals. Equation for the reaction is zinc plus hydrochloric acids arrow zinc chloride plus hydrogen gas. Chemical equation is zinc solid plus HCl aqueous, zinc chloride ZnCl2 aqueous plus hydrogen gas H2. Balance equation, place 2 where there is HCl acid. Now observation made during the reaction is effervescence occurs. Reason due to production of hydrogen gas. Now note that sodium, potassium, calcium cannot be used instead of zinc. Reason because they react explosively dilute acids. Dilute nitric 5 acid cannot be used instead of dilute hydrochloric acids. Reason no hydrogen gas will be formed because nitric 5 acid is a strong oxidizing agent, hence oxidizes hydrogen gas formed to water. Now iron cannot be used instead of zinc. Reason iron contain impurities and result in the formation of other gases, e.g. hydrogen sulfide gas. Now copper cannot be used instead of zinc granules because no hydrogen gas will be formed because it's reactive than hydrogen, hence cannot displace hydrogen on the acid. Now collection of hydrogen gas. Now hydrogen gas can be collected by over water methods. Reason because it is slightly soluble in water. It can also be collected by upward delivery. Reason it is less denser than air. Now drying agents used to dry hydrogen gas include concentrated sulfuric acid and anhydrous calcium chloride. Note that after the gas has been dried, it should be collected by upward delivery. And below shows apparatus setup diagram used to prepare and collect hydrogen gas. Now when the gas is not required dry, the gas is prepared and collected by over water method. This one, you place here dilute hydrochloric acid, you place here zinc granules. Now remember that when you are using a Thistle funnel, the funnel should be dipped in the solution here. Now after the gas is prepared here in the generator, it is collected by over water method when not required dry. So this is water here, and this is called over water method. Now when the gas is required dry, you are supposed to pass it through a drying agent first. After preparation, you pass it through a drying agent. So you place here zinc granules and the catalyst used, that is copper sulfate crystals. And then you allow the diluted chloric acid from the top here to the tap. When the condenser tap, I say it's called a dropping funnel. So it should not be dipped in solution. So you have here the gas produced here. It is passed through either concentrated sulfuric acid or anhydrous calcium chloride. If it is in a U-tube, like this case here, it is called anhydrous calcium chloride here. After the drying of the gas is collected by upward delivery because it is less denser than air. Note that in both cases, the initial amount of gas should not be collected because it is impure. That is, it is mixed with air originally in the flask. Now physical properties of hydrogen gas includes it is a colorless gas, it is odorless gas, it is less dense than air, it is slightly soluble in water. Chemical properties include chemical properties of hydrogen are 1. Effect on litmus. Hydrogen gas has no effect on litmus paper. Reason hydrogen gas is a neutral gas. 2. Combustion. Hydrogen gas does not support combustion, hence it extinguishes a burning splint with a pop sound. That is a test for hydrogen gas. So the test for hydrogen gas is it extinguishes a burning splint with a pop sound. Description of the test becomes lower a burning splint into a gas jar containing hydrogen gas. It extinguishes the burning splint with a pop sound. 3. Reaction with oxygen. Impure hydrogen, that is hydrogen mixed with air, burns explosively when ignited. Pure hydrogen burns with a blue flame to form a colorless liquid called water. The chemical equation for the reaction is hydrogen plus oxygen gives arrow water. H2 gas plus oxygen O2 arrow H2O liquid. To balance the equation, place 2 where there is water and 2 where there is hydrogen gas. The setup diagram is used to demonstrate that water is an oxide of hydrogen. Hydrogen gas is allowed the source here, then it's passed through a U-tube containing anhydrous chloride to dry it, then it burns here with a blue flame to form water vapor, that is hydrogen plus oxygen gives you water. Then the water vapor formed here is condensed by the ice cold water here to form a colorless liquid here, which is water. This is a colorless liquid here, which is water. The action taken during the experiment is ensure hydrogen gas being burned as jet is pure. Reason: because a mixture of hydrogen and air burns explosively when ignited. Now, reducing property of hydrogen gas. Hydrogen gas is able to remove combined oxygen from metals, e.g. copper and lead. A. Example 1. Reaction between hydrogen gas and copper 2 oxide. Equation is copper 2 oxide plus hydrogen arrow copper plus water. Chemical equation is H2 hydrogen gas, copper 2 oxide CuO solid, arrow copper solid plus H2O liquid. Now, observation made when hydrogen gas is passed over heated copper 2 oxide is during the experiment, black copper 2 oxide changes to brown. Colorless liquid is formed on the cooler ends. At the end of the experiment is a brown solid is formed. Colorless liquid is formed on the cooler ends. Reason for the observation made is hydrogen gas reduces heated copper 2 oxide to brown copper and is self-oxidized to water. Note that hydrogen gas is a reducing agent while copper 2 oxide is an oxidizing agent. The reaction is a redox reaction. Now, example 2, reaction between lead 2 oxide and hydrogen gas. Equation is hydrogen plus lead 2 oxide arrow lead plus water. Chemical equation: hydrogen gas, lead 2 oxide solid gives you lead solid plus water H2O liquid. Now, the setup diagram below was used to demonstrate the reducing property of hydrogen by passing it over heated lead 2 oxide. So, hydrogen gas is allowed here, is lead 2 oxide here. And then after that, we have here anhydrous copper 2 sulfate. Then the excess hydrogen is burned here. Observation made that type of experiment due to experiment becomes yellow lead oxide changes to gray, white anhydrous copper 2 sulfate changes to blue. At the end of the experiment is a gray solid is formed and a blue solid is formed. Reason for the observation made: hydrogen gas reduces lead 2 oxide to a gray lead metal while itself oxidized to water. The water formed combines in a anhydrous copper 2 sulfate to form hydrated copper 2 sulfates. Now, points to note from the experiments. It is important to drive out all the air from the combustion tube before lighting the jet. Reason: to ensure the hydrogen being burnt at the jet is pure to prevent explosion. Note 2. Excess hydrogen is burnt and not allowed to escape the air. Reason: because a mixture of hydrogen and air is explosive when ignited. Last point, it's advisable to continue supply of hydrogen gas through the tube as apparatus cools down. Reason, to prevent reoxidation of hot metal by oxygen from the air. Uses of hydrogen gas. Hydrogen gas is used in large-scale manufacture of ammonia gas called Haber process. It is used in hardening of oil to fat. It is used in hot air balloons because it's lighter than air. A mixture of hydrogen and oxygen burns to produce a very hot flame, that is oxyhydrogen, which is used in cutting and welding metals. It is also used in industrial manufacture of hydrochloric acids.